So in this problem, you can see that we want to graph y equals 3/4 x minus 2. So what we're going to do when we graph in this form is we're going to start with our y-intercept, and then we're going to use our slope to find more points to be able to actually plot our line. So if you look at our equation, again, we're remembering that slope-intercept form is y equals mx plus b. So in this problem, we can identify our slope, which is m, as 3/4, since that's the coefficient of x. And then we see our y-intercept, which is b. In our form, we know that it's y equals mx plus b. So since we have a minus 2 here, we know that our y-intercept is negative 2. So what we'll do is we'll go over here to our graph, and we're going to start on our y-axis at negative 2. And we're going to go ahead and plot a point there. Once we start with that y-intercept, now we're going to use our slope to get the rest of our points. So our slope is 3/4, and if we're remembering, we use rise over run, or a vertical change over a horizontal change. So if I start at this point here, I'm going to go a rise of 3 and a run of 4. So from here, I'm going to go up 1, 2, 3, and over 1, 2, 3, 4. And that will be my next point in my graph. We can continue using that slope to get more points. So we can again go up 3 over 4. And we can basically fill up our graph using those points. Now, we could also go in the opposite direction. So instead of going up 3 and right 4, we could do the complete opposite. And if we go back to our y-intercept, we could from that point go down 3 and left 4. And you'll notice if you do that properly, it will continue to be a straight line that will continue to line up with those other points. Once we get a couple points plotted in there, we're going to be then ready to go ahead and graph our line. So we want to take some straight edge, a ruler, or some other straight edge to go ahead and draw a nice straight line through those points. And we have to remember that with a line, we always want arrows on the end. All right, so that's it for that graph. Again, if we have an equation that's in slope-intercept form, really is pretty quick and easy to graph because all we need to do is plot that y-intercept, and then we use our slope to find the other points on that line. Let's take a look at another example that maybe isn't quite as easy as that first one. So in the next problem, we're going to go ahead and graph the equation y plus 2 equals 1/4 times the quantity of x minus 3. So the first thing that you should notice is that this is not in slope-intercept form. So what we typically want to do is we want to get this into that form. And again, the way that we do that is basically solving for y. So if I want to solve for y, probably the first thing that I'm going to do is distribute this 1/4 to the x and the 3. So when I do that, I have 1/4 x and then minus 3/4. Once I do that distributive part, we then need to get rid of the 2 that's with the y. So we go ahead and subtract 2. Just want to make sure that we're being careful with our calculation here on the right. So we're going to be doing negative 3/4 minus 2. So you can use a calculator to help with that, but it's going to give you a decimal. Sometimes that's not a bad thing, but sometimes it's going to be easier to have a fraction. So let's go ahead and let's just go into decimal form. So if we have negative 3/4 minus 2, we should get negative 2.75, or if you kept it as a mixed number, it would be negative 2 3/4. So you can see we have our graph. It's in slope-intercept form. We have the y equals mx plus b. Since this is a minus, we just know that that's going to be a negative. So let's go ahead and identify our different parts here. So we have our slope right here, which is 1/4. And then we have our y-intercept, which is the constant over here of negative 2.75. So we'll go ahead over to our graph. This one's not going to be quite as convenient to graph because we do have a decimal y-intercept, which really isn't as nice as what we saw before. So let's just go ahead and let's plot that. We know that it's going to be in between negative 2 and negative 3. It's going to be closer to negative 3. So let's come over here to our y-axis and go ahead and plot that. From there, we're going to use our slope of 1/4. So we're going to be going up 1 over 4 using that rise over run. Just want to be careful when you are going up 1 over 4, remembering that we're not on that line, but we're just above it. So if I go up 1, I'll be just above that next line and then over 4. So we'll go ahead and plot that point. And again, we could continue doing that by going up 1 over 4. Similarly, we could go down 1 and left 4 if we wanted to get more points on our graph. Typically, the more points that you have on your graph, the more accurate it's going to be. Do you need to fill up the entire graph? Let's say not always. Sometimes your slope will be scaled to the point where it will, but you definitely want, as always, at least 3 points in order to draw your line. Go ahead, take your straight edge once again and connect those points. Draw a line through those points, taking up your entire coordinate grid. And then, of course, as always, we want to make sure that we have arrows on the end of our line. One thing you always want to make sure that you remember is the slope or the sign of your slope. So in this case, we see that our slope is a positive 1/4. And when we look at our line, we can see that that has a positive slope since we're basically going uphill as we're going left to right. So always check that sign. That's often a mistake where people have a negative line where it should be a positive and vice versa. All right, so taking a look at the next one, we're going to go ahead and graph equations using the graphing calculator. Now, really, this should only be used as a check. So we want to go ahead and draw our graph on paper by hand, and then we'll use Desmos to check that to make sure that we actually graph that correctly. So here we have the equation 3x plus 4y equals 16. And if you remember, this is in a different form of linear equations, which is standard form. So what we want to do is we want to go ahead and if we're going to use the slope and y-intercept, we're going to convert this into slope-intercept form by solving for y. So I'm going to rewrite my equation down here. If I want to solve this for y, probably my first logical step would be to get rid of my x term. So I'm going to go ahead and subtract 3x from both sides. Because I know that slope-intercept form is mx plus b, I know I want my x term before my constant. So instead of writing 16 minus 3x over here on the right, I'm going to rewrite that as negative 3x plus 16. It'll save me an extra step in the end. Maybe be a little bit cleaner there. We then need to continue getting y by itself, so we're going to need to divide by that coefficient of 4 on both sides. In the past, when we solved for literal equations, we were basically allowed to stop at this point. We do need to continue further, though, because we really need to be able to see what that slope and what that y-intercept are. So we're going to go ahead and divide both of those things separately by 4. So negative 3 divided by 4 will not divide nicely, so we're just going to go ahead and leave that as a fraction of negative 3/4. And then we need our x there as well. And then we have 16 divided by 4, which would give us 4. So to graph that again, we're going to go ahead and start with our y-intercept, which in this case is 4. And then we'll use our slope of negative 3/4. So we have our y-intercept, y-axis at positive 4. Now, this time our slope is negative, so we just want to be careful with this because a lot of people tend to make mistakes. Whenever I'm graphing my lines, I always like going right with my second point. So if my slope's positive, I'm going to go up and right. If my slope's negative, I'm going to go down and right. So for this one, because it's a negative 3/4, I'm going to go down 3 and then right 4. Again, we can continue that down 3, right 4 to get some more points there as well. We could go the complete opposite direction, and instead of going down and right, we could go up and left if we wanted to get some more points on the other side of our y-intercept there. And once we feel that we have enough points to where our line is nice and straight and we can see accurately what that line looks like, go ahead and draw our line through those points using our straight edge. All right, so like I said, we can check that in Desmos. So let's go ahead and let's take a look at that graph. With Desmos, you can type the equation in any form that it's presented. So it's going to often be the safest if we input the original equation instead of the one that we solve for y. If you made a mistake along in the process, that's part of why we want to check it in the calculator to make sure that we didn't make some kind of mistake as we were trying to get that solved for y. So we're going to type that in exactly as it was in the beginning, 3x plus 4y equals 16. And you'll see your line graph there, and if you did it correctly, it should first of all look the same. It should look to be roughly similar. One good thing would be to check your x and y intercepts. So we see that we have a y-intercept of 4, which was our original starting point in our graph that we did by hand. We can see our x-intercept is 5 1/3. So it's going to be hard to actually see that that's accurate, but we can see that it's between 5 and 6. And if we look at our graph carefully, we can see that it will cross the x-axis between 5 and 6. So that's really enough to be able to see that what we did was correct. So again, just a great way to check your work by hand and make sure that you did everything correctly in there.